Perfect. Yes, thank you all for joining us today. Today we are very excited to have the grand opening of our Florida plants. So we have Jared Johnson, Alex Escribano, and a few other members of our team. They're live to take you guys on a walkthrough of our new grand opening. So quick overview of what we're going to go through today. So for those of you who are new to our live events or are new to Armorock in general, we'll do a quick overview of who we are and what we do here. Next, I will hand it over to Jared, who will take us through a live walkthrough. And then throughout, please be putting your questions in the Q&A chat, and Jared will address them during and at the end of his walkthrough. So feel free to ask away on your questions. And then at the end, we are going to wrap up with a 10-question quiz. And we have a DJI drone, jumper cables, Armorock merch, a whole bunch of fun giveaways for you guys. So please stay tuned for that to win some Armorock merch and some other fun prizes. So getting us started here. So who is Armorock? What is polymer concrete? So we are a polymer concrete manhole and lift station manufacturer. And today we're going to be walking through our Plant City, Florida plant. We also have another plant in Texas and in Nevada. In this video here, you see that gentleman there in the yellow walking through this pasture right here. He is Vince Busio. He is the founder of Armorock. He is a third generation precaster. Saw the issues going on within the wastewater system and really felt like we needed a better solution. So he went down the rabbit hole of trying coatings, liners, admixtures, and just felt like nothing was really solving the root of the issue. So he went over to Europe to see what solutions they were using within their systems, and that is where he found polymer concrete. In this video here, you'll see the issues that municipalities across the nation are seeing within their system. The Portland cement concrete is aggressively being eaten away by that H2S gas. So some of you tuning in with us today have probably seen structures like this where they have almost turned completely into dust. And our solution really works at solving the root of this issue. We substitute that Portland cement concrete with polymer, with that resin that we'll go over next. But yeah, that is what we do here at Armorock and what polymer concrete is. So quickly going into the secret sauce behind polymer concrete. So polymer concrete is composed of 4 main ingredients. So we have our sand and aggregate. Next, we have our FRP rebar. This really differentiates us and allows us to say that we are 100% corrosion-proof structures. So you may be wondering, why would that matter if you're never going to see that FRP rebar? So if you were to core into it, or for some reason that rebar was to come exposed, it will never corrode. So 100% fully corrosion-proof structures. Likewise, I mentioned that resin. So the resin we put in our secret sauce in lieu of a Portland cement. That Portland cement is the issue within the system that gets eaten away by the H2S gas. So we substitute that with a resin to create polymer concrete. Those are just a quick overview of who we are and kind of what we do here. Once again, please be sure to put your questions in the Q&A chat and Jared will address those. But I'm going to hand the floor over to him now to take you on a live walkthrough of our brand new expansion in Plant City, Florida.
We're good. You can hear us now, Dom? Perfect. All right. Well, thank you very much for joining us. This is our first time doing a grand opening and a live tour all at the same time. Alex, do you want to do a quick circle to show them what we're doing here? What he shows you is it's just started. We're running from 11 to 3 today. We have tons of municipalities coming out, other engineers and contractors, and we're going to give you a quick tour of the facility. Let's get right into it. We're going to step outside as I walk the parking lot. I'll keep talking, and then we'll slow down when we get into the first building. Welcome, you guys. Thank you for coming. Good seeing y'all. All right, we're going to have lots of people to get to say hello to today. I'm excited for them, and it's even funner to have you all join us. Funner, sorry, that's not even a word. And we're going to cut through a bunch of cars today. We're going to start in the original building here at Armorock. These buildings were originally used as a precast facility for bricks, for pool facades, facades of buildings, etc. And it started in the 60s. Phase one of Armorock started in the building in front of us here and to the left. And this is where we started with 48s through 60s to begin with. When we first started pouring here, it was a really small-time operation, but as sustainability and the need for it in Florida grew, these buildings grew. So let's go in and introduce you to where everything starts at Armorock. Again, if any of you have questions, feel free to text them in. I'll read them out loud so everybody knows the question, and we'll slow down and do a deep dive into those areas. But this is the basis of where everything starts in this room. You see a bunch of white stuff around, that's 1 pound EPS foam, and we use that to build our inverts. Alex, if you can give a nice view of the 7-axis robot here. That robot you see in that room has the abilities to carve out the exact invert or whatever solution you need for your lift station, manholes, siphon boxes, etc. Let me go ahead and unpause that machine for just a moment, and you'll see it running. You'll see that head rotates at several thousand RPM per minute, and it takes about 45 minutes to carve an entire invert. The section it's doing right there is actually a pipe bed. That's going to show how far the pipe's allowed to come into our structure. And then it's going to round off that entire product. Again, it takes about 45 minutes to complete that. These machines run 24/7, and we have 5 of them throughout the country. All right, Alex, follow me. After it completes with that process, it looks just like what we see here. This is a great example of it. I'll let Alec kind of show that on camera. And this is the opposite of what you're going to see when we're done completing it. A lot of people ask, is there styrofoam in our product? There is not. This is only used for molding purposes. And something important that we do that no others do, by using that 7-axis router, I get the perfect transition every time. I get very smooth runways. Those runways are designed for your effluent or the sewage to come through the manholes. And the cleaner we keep that from agitation levels, the better it is. We're going to have less H2S problems downstream. After it comes out of the machine, we'll smooth this out one more time. We hand sand it, and then we hard coat it like what you see here. The hard coat is designed for 2 purposes. It's designed to protect the foam so we can reuse this, make it as recyclable as possible. We're going to put this back into use. When we're done, we'll keep a library of it. Once it's destroyed, we're going to grind this up and use it in a recycling program. You can see how perfectly smooth those inverts are. When we see the finished product, you'll see exactly why that's important to have a perfectly smooth product. After it goes through here, while we're in this building, I just want to show you some of the accessories. Accessories are a common thing that we'll put out with all of our product. I'm going to show you a couple examples of those here. We typically will just follow whatever municipality standards are for boots and accessories, and then we'll supply them. And I'm going to give you a couple examples of that today. Believe it or not, this is a boot. It's actually folded inside of itself right now. This ring right here is going to become an integral part of our wall. So our wall is going to be cast around that. This is a boot that eliminates the stainless steel expansion band there. It's a really good way to eliminate any I&I potential. And then, like I mentioned, that opens up into a boot that clamps around the pipe, just like a traditional boot that you see here. This is what you'd see on a traditional job site. This is an expansion boot. You tighten this bolt up, and this expands and fills the hole, eliminating any I&I or inflow and infiltration coming through that area. And then you have the stainless steel band on the exterior of the pipe to make sure we have a solid seal. At Armorock, especially in high water areas, we use a rubber gasket on all of our spigot and valve designs. I like to call it a wedge gasket because if you were to look at a profile of it, it's thicker on the bottom than on the top. That allows the bell to home easily over it. And then when it's locked into place, any exterior water pressure that comes in pushes up against this flange and actually makes that gasket tighter in our system. Again, eliminating I&I is high priority. On top of our spigots, and we'll show this later on in our walks, we're going to use a ram neck or a mastic, just like a traditional precast structure. In high water areas, there's a lot of belts and suspender type of scenarios here in Florida. And the reason why is because of that water. You can also use exterior wrap. This would be designed to go around the bell and spigot. This is specifically a heat shrink wrap. Again, eliminating water. We're commonly asked the question, I'll probably be asked it today, if we can put ladders or steps into our product. Yes, we can, but we've specifically designed products that don't allow them. Per OSHA standards, we don't want people down in those holes, so we're trying to eliminate those. If you need them, we commonly suggest going to products like this polypropylene ladder, high density, that gives you the ability to have a corrosion-free product. It's not going to bust out of a wall like a traditional step, and it gives you that security to get in and out of that properly. Grade rings. We follow whatever your municipality standard requires. The only thing I would suggest is don't use concrete, but you can if you like, but it will corrode. So commonly we're going to use polymer grade rings. We make those here in the shops. We make them in 2, 3, 4, 5, 6 inch lengths and could custom do larger ones if necessary. We will use 24s, 36s, etc. This is an interesting product. This is called LabTech product. Again, I sell this product. I'm not a vendor for them, but it's interesting, so I like to share it. It's essentially a plastic, and it's injection formed, and they'll use these grade rings and stack them up to whatever desired thickness. They seem to have a lot of good attributes when it comes to I&I. We also have Cretex grade rings. Let's go ahead and give an example of the Cretex grade ring. Again, it's a tongue and groove on the Cretex, so they're interlocking together. HL93 load rated, another really good product. They're lightweight for easy installation. Just some good options out there. We'll follow your standards. When talking sustainability, this is a common product here. This scenario is, I believe this is EJ. It could also know this is a cap, sorry. It's a cap product, full composite lid. It will never corrode in your system. One of the nice parts about these, they are gasketed to allow no water through there. In Florida, and I know it's hard to believe, especially if you're in the dry states, there was a report out a couple years ago that said $900 worth of water every year goes through just the ring and cover of a manhole. So every municipality is scrambling to find products that will allow no water into there. On the side note to that, if you have a manhole that's sealed like this, then that H2S has no way to escape. So your concrete manhole will break down quicker. Luckily, with our sustainable products, we can cap this and the H2S doesn't affect our product. As we walk through the building, you're going to see the styrofoam in back of me. That's where everything starts. And now we're going to take you into our production facility. I'm going to walk a little fast as we go through the parking lot, but we'll talk as we go. To my left here, you're going to see those large tanks. Those are for our polyester resin. Remember, Dalton gave you the recipe of our product a little earlier on. It's resin, aggregate, and sand. That's what holds our resin right there. It's 7,500 gallons per tank. This building has 4 of those on them. And they're filled up almost daily. It's amazing the amount of work we run out of this little building. As we come back through here, you're going to see a lot of construction going on. This building to my left is brand new, and that's what we're introducing today. The one to my right was officially opened up as Armorock in 2020. And then we went straight into COVID, and we had major delays and started pouring around 2021, 2022 area timeframe. All right, welcome to our facility. Again, all of our rooms are under construction. So I'm going to show you our fiberglass room. Integral part of our product is fiberglass. We use an ACI 440 rated rebar. But it's not traditional rebar like you would be familiar with. Alex, let's go ahead and give a quick zoom in on this so they can see this. This is a fiberglass rebar. Show it away from my shirt there. It is textured. That's so that the resin has abilities to attach to this. So when they expand and contract equally, and we have no movement there in your product. Now, this is a very strong product. It's a DOT rated product here in Florida. That rating, the ACI rating, also shows that you can install it in all of our products. There's all different sorts of lifting hardware and spacing hardware that we use. These are designed to be spacers. When we have a wall of our molds, this makes sure that that bar is directly in between right where we want it. This is a great example of a fiberglass lid. At some point, we'll cut a ring and cover opening into this product. Note that we don't use steel in our product. So even the attachments to hold everything together are a polypropylene plastic, high density, no steel is used on that tie. Fiberglass, you cannot bend the shape. So when we order our fiberglass, we order it in round cylinders like you see in the background that goes around our structures. If they're building boxes, we have 90-degree turns. Those are also used on lids at times. This is a good example of what one of those round structures comes with. Remember, it comes with the shape from the factory. So that would go in the wall of a product. And those come in just like traditional steels, size 3, 4, 5 are pretty traditional. And we can go smaller and larger when necessary. Now let's get into the recipe that we already gave you. We talked about the resin outside. It's a polyester resin. Depending on what's needed in the industry, we can go to also what's known as a vinyl ester resin. That's not needed in the sewer industry. That's more for industrial applications where there's even higher levels of acid. But everything starts with the aggregate source number one. In traditional precasters, they use a lightweight or a limestone style rock, easy to crush, a sandstone, but those are not inert to corrosion, so they break down quickly. So at Armorock, we found that quartz, that's what we're looking at here, this is also known as a river rock, has the abilities to hold up to all the H2S levels you have. We also can use crushed granite, and also use crushed quartz at times. And then we finish it off with sand. Sand is a filler. That's the one thing in Florida, as you can see, we create a lot of. We're proud to use our own Florida sand in here. In fact, that actually brings up a point. It is an American-made product through and through. Resin, aggregate, and sand is all American-made. Once we take those products, we're going to put them into our mixing machine. That's what you see here. This machine will take those three products, blend them all together. This is an auger system that you see. When it gets to this bit here, it's going to grind up those three materials, execute it, shoot it out of the end here, and this box can put out 350 pounds per minute. We can go much higher than that if necessary, but that's our traditional rate speed. As that's coming out, we have a carousel here, and that's so we can put a riser here or a mold section, and that rotates around as the material's coming out. It takes about 10 minutes to fill up a traditional one, and this will be running all day long. In this table, we do have vibration capabilities if necessary. With our product, it takes very little vibration compared to traditional precast. It is more of a liquid form when it comes out, so we have a product that comes out with no air entrapment and no gateways for water to get through. Polymers. Everyone wants to know, why is it precast material? Why can't we do it in the field? It's very temperature sensitive. So here in this plant, this is Florida. It doesn't get very cold, but when it does, we're going to use heat blankets like you see in the background. As we tour through here, you're also going to see heaters. So this is a good example of the blanket. These are insulated. There's two different types of blankets. There's insulated blankets, and then there's also plug-in blankets. Those will be commonly used to make sure that our molds are heated to the proper temperature. If we leave these cold when we put our material in there, then you're going to end up with a surface that's not a beautiful piece of work on the outside. We like our product to look beautiful. Heaters that we spoke about. So now we've gone through the fiberglass, we've gone through the materials, and we're going to introduce you to our mold systems. And this is really where you start understanding what that foam was all about and why we do it. I showed you the hard-coated product. This is a good example of that. Now notice that yellow product has a green tint on it. That's a water-soluble primer or a wax. That is a mold release, essentially. That gives us the ability to move it. I'm sure, do we have any questions? If not, this is typically where I do see a question, and it's always right here. There is steel in our product, and it's only in our A anchors. This is the opposite of what you'll see later. I'll show you the return of this once completed. This A anchor is designed for a three-way pick of our manhole bases. Essentially, you can throw it away when we're done. You can cut it out. You can cap it. It doesn't transfer to any other bar in our product because there is none. So you don't have to worry about that, but that is it. So the foam has now been put in here. This is what's called a hole former here. You remember earlier I showed you the gasket that gets cast into our wall. So now this represents the pipe that's going to come in. Our product is going to be cast around that and encapsulate this piece. That eliminates any I&I there. What you see here, this represents the pipe that comes in. That's going to be the bed it sits on. I'll give a great example of that. And in Florida, we have anti-flotation collars. You're going to see that in a lot of our views. Now, those can be expanded out and in thickness for the purpose of anti-flotation calcs or from your geotech. So if there's high levels of water, sometimes we will make those larger. Right behind us, this is a product. At Armorock, our goal is to have 85% of our product not need any touch-up. This product was made yesterday. There's still actually a little bit of warmth in the product, and it's a good example of the quality level, what you see here. Now, this is upside down. The reason it's upside down is because the most important part of our product is our spigot. We'll show you an example of the spigot later. By pouring that first, that eliminates any potential air bubbles or any inconsistencies. That's where our gasket's going to go and our two sections come together. Looks like we have a question for you. Let me just read this out loud really quickly. Good thing I have my glasses on. It says, with cast-in boots, is there ever a way to adjust them post-production for uninspected or unseen need for an invert or elevation? Great question. Yes. First of all, a boot has 7 degrees of deflection, left, right, up, or down. So a pipe can come in and move that much. Most municipalities actually have specifications on how much deflection or change in pipes are out there. Here in Florida, it's typically around 3 degrees. So we can design our pipe bed to make sure we match your requirements. So if a contractor's outside of that, they're either going to have to make a field adjustment or move on and do something different by replacing it. But yes, you can do that. If you have a product that's completely off, we can actually core through our product and you can put in a new boot, and I'll show an example of that. We have one more question here. How are the polymer grade rings installed? Is it an adhesive or just mastic? It's typically just mastic, but you can also use a polymer grout. Our polymer grouts are made from the same material minus the aggregate, and you can mix those up in the field. Thank you for those great questions. If any more come in, I'll answer them. Hole formers. We talked about the hole former. This represents where the pipe comes into our product. This is what it looks like, or very early stages. That would pull out of this product, and then they're going to vacuum out this foam insert and pop this off of it and rotate it over, and this one's ready to go. Again, just look at the quality of those edges. There's no bug holes. We haven't deflashed anything yet, and you can see how clean these scenarios are. Here's that boot that we spoke about earlier, how it unfolds. It's a great example, actually. Didn't know this was here. So that's what the boot looks like. You can see the foam. Have they already pulled the foam out of there? It looks like the foam has been pulled out of the center already. So great example of our products there. As we go down in this room, we're going to do 48s, 60s, 72s, and 96s. All right, we also have a question. What kind of testing is done at the plant? We have so much testing, and actually we're going to highlight some of that here shortly, so I'm excited to show you that. We do some testing here that's unprecedented in the industry, and we'll introduce you to that today. 96-inch riser, again, look at the quality as we go by, again, has been untouched. Our goal, again, is 85 or 89% of untouched product going out the door because of those quality levels. Once the product comes out, it comes into the finishing area that you see here. This is product that was done in the last 5 to 7 days. And I wanted to specifically show the interior of this product. You can see how smooth those inverts are. And you see the transitions are perfect. So as that pipe comes into those sections, that pipe is going to set right here. And then you're going to have invert of the manhole versus invert of the pipe, and you're going to have a perfect transition. By making a perfect transition, we're going to minimize the agitation which creates H2S, and then thiobacillus has a gateway to destroy your product. This is a good example of that pipe right here. If you can show inside, Alex, you can see the pipe homed there, and you can see that perfect transition going through into there. In some municipalities, they like to fill what's called the annular space here. That annular space isn't necessary to fill, but if you want to keep toilet paper and other things from building up here, you can fill that with our polymer grout. And lastly, Alex, do you want to step up on the ladder? This is an interesting manhole. I was glad to see this. This is called a beaver slide. This is kind of new to the industry. Most precasters don't have the abilities to build this, so we build these beautiful transitions. So as you can see here, there's the large lateral coming in where I am. That lateral's 2.5, 3 feet above the bottom jack. So in normal situations, you would do a drop, inside drop manhole or an exterior drop. Drops are notorious for building H2S. They're notorious for rehabilitation needs. So we eliminate that by making the roller coaster here. That's where the product flows in here and it goes down the invert at a smooth transition back into the trough, eliminating that agitation. If you need any of those, you need to follow your municipality standards. Most municipalities don't know about those, so you can introduce them to it. And more than likely, they would love to try it. Our municipalities here in Florida love them, and we use it on almost all jobs now. Alex, follow me, please. Innovation is a large part of what we're doing here at Armorock, and I'm going to show you one of our newest forms. This will be in use, has been used a couple times already. This is a 96-inch riser section. The innovative part about here is down here at the base. That base has the abilities to vacuum suck out that foam that we talked about earlier. By having it pulled out of the product here, eliminates movement. And when we eliminate movement, you have a quality product that will never fail. Have another question? Perfect. Let's see that. We're doing good on time too. All right. How easy is it to replace a boot in the field? It depends on the boot, and that's another great question. If it's a bolt-in boot, that's the one with the stainless steel band that we saw earlier. It's a very simple process. You pull it out, you put a new one in. If it's a cast-in boot, you're either going to have to core that out and then put in a larger boot, or you're replacing the manhole. So there is a byproduct to everything. There's always good and bad. Cole, that's a great question. So on a cast-in boot scenario, rarely, if ever, have I ever seen a need to replace those. In fact, I have never replaced one, surprisingly. Contractors are notorious to say, we're going to rip it, it's going to be a problem, but I've never seen one rip. It's not to say that it can't happen, but I haven't seen it yet. If you did, you would core it out, put in a direct drive boot, and then move on. Thanks for the question, Cole. As you see, we have some tours going on in the background. It's a great day here at Armorock. We're excited everyone's joined us. Now we're going to go on to some of the innovative things that we're doing at Armorock that changes our capabilities. And we're going to go introduce you to our QC lab. In our QC lab, we're going to show our cylinder brakes, and then we're going to follow it up with our most innovative thing to point, which I'm excited to introduce to you. All right, in the QC lab, we're going to show you a cylinder brake now. And in here, we're going to understand what our standards are, first of all. And our standards are 1, 7, and 28 day brakes. Is that 1, 7, 28? I'm going to stand here so you can kind of talk about that. So when we do our 1, 7, and 28 days, we're going to take those cylinders. That's what you see in the background here. Are these 7-day cylinder brakes that we hear? Okay. Okay, 1, 7, 28. And we're going to put it into our machinery here. This machinery is actually going to do a compression test. And this tells us how strong our product is. And if we're holding up to the ACI 548.17 standard that's out there for polymer. That's a new standard. It's a national standard. We're very proud of it. That standard is really elevating the game. For instance, in that test, there's a 6-acid, strong acid test in there that tests your product for corrosion. In the concrete standards of ASTM, they don't even have that test. And yet rehabilitation is a process that's taking place in all of our sewer systems, and we don't have tests to actually improve that. All right, we got another. Oh, we can't hear the other guys when you make sure. Okay. And this is a live tour, so I'll make sure the other people are next to us when they are talking. And as you can see, I'm not smart enough not to read it out loud, but that's all right. So what you see here is well, go ahead and explain what's going on here.
So right now, we bring it up to 2,000 PSI as our standard, so quarter of 10% of our overall load. So then after we get that, we bring it over meter advanced and adjust down to where it's from 40 to 45 pounds per second. Wait until it breaks. Oh, we'll wait until it breaks. Then we'll pull it out. We'll see what kind of break it is. We'll see the aggregates sheared in it. See if there's any free resin. Make sure that we don't have bug holes or void spaces within our cylinders. Yeah, we're about waiting game until we get it.
Yeah, it's an interesting waiting game because this part usually scares the heck out of me.
You anticipate it.
Yeah, you can anticipate it. You kind of have an idea as we watch these standards here. Go ahead and pull in here. You can see the ultimate break up here. This is those PSI ratings. The true tattletale of when it's going to break is when this PSI starts dropping. When that starts dropping and gets to 0, we're close to a break. And that's when it's a very loud noise. It typically scares the crap out of me. And I jump and scream like a girl. This is a fun process. As that's going on, we'll show you a little bit of what else is here. We talked about 1, 7, and 28 day breaks. Everything is dated. How many do we pour on a typical day? How many samples?
Machine. So we got 4 machines.
12 going. No, 16 going.
Yeah. Well, we pour an extra for day 3.
Okay.
That's just to see our progress on our end. To make sure that we're getting a good strength increase in between day 1 and day 7. So we'll pull 4 per machine, and then if we're doing an adjustment to our mix for a specific piece or pour, we'll take an additional set of 4 samples for that as well.
To give you an example of that, in the precast world, it's 4,000 PSI on their rating. Typically, they're breaking between 5,000 and 7,000 PSI. Polymers are 3 to 6 times stronger, depending on our mix design. So we're per our ACI ACI 548.17 specification, we're 10,000 as our minimum. And that's what we're going to look for here is we want to be over 10,000. Currently, we're at 10,700. Is that correct? Which is good. You notice the PSI is starting to drop now, very slowly. This one is going to make a heck of a lot of noise, and I'm going to get scared. This is not good. I don't like when they take this long. It makes me nervous. A fun story, in the early days, we would use this same machine, but it was designed for concrete. When we were a concrete producer before we went to polymer, the machines would break. We would commonly blow out the hydraulics, and we have even gone as far as bending the machinery. So we have a more updated or a stronger version specifically for polymer. When we're done with this room, we're going to go out and show you our next phase of our program. And that's where we get really interesting in what we're doing out there. It makes us different than anyone else in the industry. We also believe it's going to change the way we look at the industry. Okay, the PSI number has now dropped to 0.0. That means it's already got to its full break potential, but then it actually goes till it blows up. So our rating on this cylinder is 11,923 pounds. Go ahead and zoom in on that a little, Alex, so you get scared and not myself. Get in close to that thing. Yeah, keep your eyes closed. You got glasses on, but you get in there nice and close. Okay, I'm glad I wasn't on camera because I did just jump there. So again,
we got an 11,923 PSI brake. Pull this out the machine. Get real good close on our aggregates and the shearing of our rock.
The important part of the shearing is that it works as like a rebar in your product. This is what's holding everything together, and you get huge compression to it. So you're looking for rock to make sure it's all broken in half, and you need to have a specific percentage of it to make sure your brakes are correct. Typical in precast, you're looking for a different type of brake. This is a little different than precast in that scenario. They're going for what is considered an A brake. Ours don't quite break that way because of the strength of our product. So yeah, thank you for showing us around today. All right, Alex, let's get on to the fun one. As we're always looking forward to new innovations in our product, we're missing our person here. All right. Come good. So as we're looking for innovations in this industry, we're changing the way we think about things. I&I, inflow and infiltration of water, is a big cost to municipalities. We talked earlier about concrete having 30% air entrapment in their products, so they have gateways for water to come through their walls. That's usually what's causing the liners and rehabs they do to fail. Our products are inert to I&I. That's because it's a polymer product. We have less than 3% air entrapment. But there are always breakdowns in that. If something's done incorrectly, you could have water, like around the boot could fail, the pipe could fail. So we're going one step further, and we're quality controlling all of our products and vacuum testing those like you would in the field in our plants. Eventually, you'll see that for all sizes of our product, hopefully later this year. But right now, this is an example of what that 48 works. You'll go ahead and show them what you're doing there and explain to them what you're doing.
What we're doing here is we're going to charge the system and vacuum it up to 12 mercury. And we got what's called a dwell time. So it's going to sit at 12 mercury for about a minute to allow any temperature changes or volumetric changes inside of the structure itself to adjust. And then once that, we'll back it back down to 10, and it'll have to sit there for the testing period of a minute. As long as we don't lose 1 mercury within a minute, it passes. If you lose 1 mercury, it fails.
When it fails, are you able to track down where the fail point is?
Yes. Generally speaking, we'll use like soap and water.
Yeah.
We'll spray the structure and try to find the leak there, and just continue on from there.
In some scenarios, you can go ahead and start that as we talk. In some scenarios, you can actually repair it. If it's a boot, sometimes it just needs to be tightened up. But in a lot of scenarios, it is pull out and replacement. You won't use it. But it is also a tool for us to learn from. We've found that very few of our products will ever have leaks, but it is a good point of practice And we believe that the industry in general will be doing this in the near future, as all precasters will want to prove their products are the best out there. While he's pulling that number up, you can go ahead and show that on your camera, Alex. You can see the number has risen there. He's going to do a quick calculation on that. That's what you see him doing. What did you come up with, Bronson?
Right now, I'm just actually setting up a timer to go ahead and time the dwell time. It has to sit for an entire minute. And then, like I said before, as soon as it reaches that minute, we'll drop it down to 10 mercury,
Okay.
let it sit, and that'll verify our testing.
Perfect. Fantastic. We look forward to those results. While that's coming out, this is a good example of a riser section. We talked earlier about the spigot. This is where the gasket sits here. This is imperative that the quality is high here. This is a product that was pulled out of production yesterday. There's been no touch up on it, and you can see how perfect that is, so that that gasket sits properly on here and gets a perfect. Look at the inside view here also. Again, we talk about having a product with less than 3% air entrapment. Notice you're seeing no bug holes, no waffle joints, nothing going on, no spalling, no cracking. It really is a beautiful product. All right.
So now we're at our minute of dwell time. So now we go ahead and drop it down 10 mercury to start the actual testing.
And what were you looking for again here?
10 mercury. So we're at that now. So now we're at our 10 mercury. We close all valves and we start our timer and let it sit for another minute.
Okay.
And as long as we don't drop, we drop less than 1 mercury, it's fine. But if it hits 1 mercury at all, that's an automatic fail.
This is pretty traditional for an ASTM standard, has a vacuum test standard, and those are what we'll follow in this testing scenario.
Standard is C1244.
C1244. Huh. Good man. I don't know that one. So look it up if you want. And this is also interesting. Some municipalities, as we build this technology, are going to write specifications as they move forward. If you want to work in their municipalities, this is something that's going to be done. That's happening here in Florida to make sure the highest level of quality is going out. In the interest of time, let's pull this one 10 seconds early.
All right, so we can go ahead and do that now. 10 seconds early. As you can see, we have not lost any pressure at all. The vacuum is still at 10 mercury, so our product is perfectly sealed.
Bronson, thank you very much.
You're welcome, sir.
If any of you have questions on that, we have a full solutions team that will be able to give you more information on that and work with you to show you what you have. All right, in the background here is our new facility. So I'm going to go show you our monster building. This building has the abilities to make anywhere from a 96-inch product all the way up to 192-inch in round diameters. They can make boxes in here, all shapes and sizes. This is where you, the engineer, consultants, and municipalities get to come up with creative solutions, and this building's going to have the potential to make it. We're going to be doing a ribbon cutting here in just a little bit, and then we're going to be turning it over to Dalton here in just 5 more minutes. So let's take you through what we're doing in here. In the last building, we showed you our 7-axis robot. In here is our monster 7-axis robot. The differences are here. This has the ability to carve out 120-inch monolithic bases. The importance of a monolithic base is to eliminate joints. Now, this one has the abilities to move left to right to make larger ones. The table also rotates, and then you have full access of the arm here. In the outside of this room is our foam recycling area, just like you saw before. And behind you, Alex, is our spray booth. This gives us the abilities to cast or hard coat those very large products that we talked about earlier. Now we're going to go into one other room here. It's going to get a little bit louder, but I'll introduce you to some finished product and show you some of those different things that we have going on. We talked about auto casters earlier. Here's 2 more of them. This is in our large facility. These have been tested, vetted, and are actually in production now. Not today, but they are in production now. We have 40-ton cranes that run through here. We can cast upwards of 60,000-pound parts and ship those out to you. And in the background, you're going to see the 16-foot structure on the left. There's some 48-inch manholes in there to show you that comparison. And then on the right here, let's talk about this anti-flotation collar. Anti-flotation collars are used for water to make sure the product will not pop out of the ground. Even concrete structures can pop out of the ground if you don't have a collar. So depending on your geotech reports, we're going to make that anywhere from 6 inches upwards of sometimes 2 feet in width or in depth to get there. Looks like we have another question here. What happens to the product when it does fail? That's a great question. We've installed over 30,000 products to date. We have never had corrosion in our product. So on that point, Cole, no product has ever failed. That's unprecedented in the industry, and we're very proud of that fact. As far as breaking is possible. If a contractor was hit a product, you could break it just like you could a concrete structure. We're absolutely as strong or stronger than concrete in every way, so it's not easy to break, but it is possible. And in that place, you would fully replace it. Let me give you the last example here, and then I'm going to turn the time back to Dalton. This is a good example of how our products install. This is a spreader bar. We've designed our products to pick them with 90-degree lift points. They simply screw into the side of our product. You lift that up and you can move it around your site. As I say goodbye to you, Alex, go ahead and show the people here. Thank you again for all your commitment to Armorock over the years. We look forward to working with you on your sustainable products. Dalton, we're turning the time over to you, and enjoy the Kahoot. This is a lot of fun. Thank you so much.
Perfect. Thank you so much, Jared and Alex. We appreciate you taking the time to take us through the plant today. So I'm going to share my screen here, and we're going to do a quick 10-question quiz. So for those of you who are new and have not played a Kahoot with us before, this is a quiz that both is important to answer the question very quickly and correct. So keep that in mind as you're going through these. All the questions are very relevant to what we talked about today. And then, as I had mentioned, the first place winner is getting a DJI drone. Second place will get some jumper cables, and third place we'll get some Armorock merch. So definitely make sure to be getting these correct and answer quickly. Likewise here, the top 3 winners, can you please put your email address in the chat, and I will reach out to you to get those prizes for you. I'll also put my email in the chat if you have any issues putting yours in the chat. One final thing to mention here also, after this quiz, I'll have the QR codes up for feedback and for PDH credit. So keep that in mind if you would like to be brutally honest on feedback, as well as if you would like some PDH credit. I'll give it just a few more seconds and then we'll get started. Okie dokie, here we go. Question 1. What is the name of the machine used to mill the foam? Jared had also mentioned that there is a monster one of these machines as well. We have Pico machine, the green machine, foam master, or mill machine. Correct answer is Pico machine. We have MJB in first place. Question 2. What type of reinforcement do we use in our structures? We have steel, FRP, no reinforcement, or wire. Correct answer is FRP. Seems like most of you got that one correct. They'll have MJB in first place. Question 3. What is Armorock polymer concrete's compression strength? We saw that today. It exceeded what's going to be on this quiz, but what is the standard that we hold ourselves to? We have 5,000, 7,000, 8,000, or 10,000 PSI. Correct answer is 10,000 PSI. And as we saw today, it broke at 1150. So exceeded that 10,000 PSI today, but that's what we hold ourselves to. MJB is on fire with 3 correct answers. Question 4, what do we do with the excess foam after we mill the invert? Throw it away, recycle, burn it, or sell it? Correct answer is recycle it. We try to be a green company, so we recycle that foam to be used for other purposes. Question 5, true or false? The expansion allows us to do in-house vacuum testing. True or false? Correct answer was true. So that vacuum testing is what we got to see a sneak peek of outside the plant there at the end. So I'll have MJB in first place. Question 6, on average, how long until we remove the structure from the mold? We have 1 hour, 5 hours, 24 hours, or 48 hours. Correct answer is 1 hour. So that is one of the huge benefits of polymer, is that we're able to remove it from the mold very quickly. So for emergency situations, definitely feel free to reach out to us. Question 7, true or false? You can core into the product after production and in the field. True or false? Correct answer is true. You can core into our product after production and in the field. They'll have MJB in first place. Question 8, how often do we compression break our products? So is it every 7 days, whenever we want, every 90 days, or 1, 7, and 28 days? Correct answer is 1, 7, and 28 days is when we compression break our product. 2 more questions left here. So question 9, what size structures will Florida now be able to make after the expansion? So we have 48 to 192, 24 inch to 72 inch, 42 inches to 120, or 60 inches to 144 inches. Correct answer is 48 to 192. So with the expansion, we will be able to have full capabilities to create large structures. So reach out if you are interested in a 192 inch product. Final question here, question 10. What types of products can the monster robot produce? You have manholes, lift stations, box structures, or anything you can think of. Correct answer is anything you can think of. So if you guys have custom structures that you're interested in making, we have a full in-house engineering team who would be able to support you. So definitely feel free to reach out to us. Thank you guys all for playing. So as I mentioned, third place, Shane, you have some Armorock merch coming your way. Lindsay, you have some jumper cables and Armorock merch. And then in first place, we have MJB, who will be winning the DJI drone. So the 3 of you guys, please put your emails in the chat. I'll put my email in the chat if you have any issues, and feel free to reach out to me and we will get you those prizes. Now I will share my screen one more time with the feedback form and PDH credit. Thank you guys all again for joining us today for our live event with Jared and myself. We appreciate you guys all tuning in. I'll leave this up here for a few minutes, so take your time to make sure to fill these out. But once again, really appreciate everyone hopping on today.